Hi, this is Scott from ThinkIQ, and this is the second part of a couple of videos that walks through the use of the CESMII Smart Manufacturing Profile Editor to create equipment definitions and then use them in a partnering software application. In the last video, we created a definition for a 1,000-gallon batch tank. We labeled it the BNS 1000. We did so as if we were a member of a company called Batch and Stir who makes batch tanks and is a CESMII partner, and leveraged the CESMII Smart Manufacturing portal to create a definition of our batch tank so that it could more quickly information enable that batch tank for use in other CESMII partner software applications. We're going to change gears a little bit here and log into an application from ThinkIQ. And in this case, we're going to assume a little bit different persona. We're going to be acting as if we are part of a manufacturing company called Acme. And Acme is a contract beverage manufacturer. They make all kinds of different things from gable top cartons to bag and box solutions, etc. And in this particular case, Acme has recently replaced a batch tank on their production line. The physical implementation is done, but they want to information enable it and make it part of this ThinkIQ solution so that they could better take advantage of the functionality that ThinkIQ brings. If we take a little bit of a look at the process overview, just to acquaint ourselves with this particular operation, it's a fairly simple batching process where there's a series of receiving tanks that introduce different sweetener products, a couple of tanks for colors and flavors. Those particular receiving tanks feed batch tanks, both for sweetening and for color and flavor. Those are mixed together and then used to feed use tanks, which are feeding an inline blending process where the solutions that are made in both of those cases are combined, and then water is added to them to ultimately make a bag-and-box syrup product, kind of like you would see soda pop in restaurants. The material moves from the inline blending to accumulation tanks, which then feeds a bag-filling production line. And so in this case, Acme has recently replaced this color and flavor batch tank, and the idea is that we want to use the smart manufacturing profile to basically define the batch tank that's now in place and make it available in the ThinkIQ system. A little bit of data about the ThinkIQ system. It's a cloud-based application that is designed to collect data from on-prem, connecting to a number of different data sources, bringing the data to the cloud, and then providing different analytic tools primarily focused on material movements and traceability, but also other process analysis and performance improvements. To get the data into ThinkIQ, you simply download a connector. There's a number of different data sources available. In this case, Acme is using an OSI Pi Historian, so we use the OSI Pi Historian connector, and you would effectively download the connector to your on-premise resource and then run an MSI, follow the installation steps, and the data starts sending itself to the cloud after a little bit of a security handshake. Leaving that aside, if we were to look at the ThinkIQ application, we have a process layout that reflects the modeled version of the process we were looking at in a PowerPoint slide. And while this looks similar to the PowerPoint, it's not quite right. I have flavor tanks and color tanks here, but they seem to be a little bit orphaned. They're not connected to the batch tank that they should. There is no batch tank feeding this use tank, etc. The sweetener line looks about right. We have sweetener 1 and 2 feeding the batch tank, feeding the use tank, inline blending, water comes into that, accumulation tanks, and off to our bag filler. So what we're really trying to do is to say, can we leverage the smart manufacturing profile to simplify the integration of that batch tank? Well, the data is already being collected in our historian. And like I said before, we have an OSI Pi connected to this via ThinkIQ gateway, and we can verify we're getting data in our historian if we look for, historian tags like sinusoid, just to kind of establish that, yeah, we have some data there. We could take a quick look at that and say, yep, that looks like my good old sinusoid. So I'm confident that my historian's connected right, but we need to tell ThinkIQ to get the appropriate tags, bring them in, and start collecting that data. So what we're going to do is go to our model editor, which is the interface in which you can define your system model. So we have our Acme company and Aliso Viejo, the flavored syrup plant, etc., and various process areas on that. We define equipment types and equipment attributes, etc., relationships, tags, and so on. But in this case, what we really want to do is import the profile. And this Profiles tab is designed to point at different profile sources. In this case, we're only connected to the CESMII profile collection. So there's an API on the CESMII Smart Manufacturing Marketplace that exposes the shared profiles to applications that are designed and authenticated to do that. And in this case, we can see all of the different profiles that we saw shared on the CESMII site. So there's our BNS 1000 tank, the 1,000 gallon batch tank we created in the last video. And we could, scroll through here and we could see all of the other shared profiles as well. But obviously the one we're interested in is this guy. So by selecting it and clicking our import assistant, we start a little bit of a wizard here. We can first validate that, yes, those are the attributes I expected to see on this. And while this is simplistic for a demo, it reflects what we created in the last video. I could go ahead and click the next button and say, okay, this is the profile. And we have a choice. Do we want to simply create a type definition in the ThinkIQ system, which would allow us to create instances of the BNS 1000 type later? Or do we also want to go ahead and just instantiate an instance of this data type now? Sorry about that. Okay, I'm going to go ahead and say yes, we want to create an instance, and we're going to call this the color and flavor batch tank, just like we had in the PowerPoint. And we're going to say it gets its data from the OSI Pi connector. And this is kind of important because by selecting which connector we get our data from, it dictates a little bit of the rules on how we do any mapping to the default attributes that were defined in the profile itself. So if you remember, we mapped out a couple of different default addresses for tags. Under the covers, the ThinkIQ system understands that if I'm getting the data from this source or that source, this is how I would go about resolving that. And it's a little bit source by source specific, and in some cases it's not possible, but ideally we try to make this as easy as possible so that it's fewer and fewer steps for our users. So if I go ahead and click import, what's happening now is we've just imported the type from the CESMII system, we've created the type, and now we've created the instance. So we can see here on this little pop-up, I can navigate to the type definition, or I can navigate to the instance definition. So if I come here, we can see my color and flavor batch tank. It's of type BNS 1000. It lives in our processing area because that's my default processing area. And off I go. If I look at attributes, I can see the same attributes that we defined. I think this looks pretty good. If we look at our process layout, I can see that I have my batch tank now, but it didn't quite fill in the gap magically. Now, it would have been great, but I think that might be just a little bit more than is reasonable to ask of the CESMII Smart Profile. In order to really make that happen, we would have to know what are the sources, the inputs and the outputs of this. And as much as the batch and stir company making the profile knows all about the definition of the equipment, they don't necessarily know how the equipment's going to be used. So in this case, I still have to do a little bit more work to establish the relationships between this batch tank, its receiving tanks, and the use tank that it feeds. So I'll bounce back over to my model editor. And in this case, I will go to equipment and find our color and flavor batch tank and say, it needs to have a relationship, and that relationship is a can feed relationship, and it feeds our color and flavor use tank. That's part of the equation, but I also need to say our color tank has a relationship that feeds the batch tank. So let's go ahead and do that. And color and flavor batch tank. and the flavor tank has a relationship that feeds the batch tank. Can feed color and flavor batch tank. Great. Let's take a look in our process layout now and see if that didn't clean that up a little bit. Outstanding. So now we can see two distinctly different lines here. We have our sweetener line that feeds our inline blending and our color and flavor line that feeds our inline blending, ultimately feeding our accumulation tanks, etc. If we were to look at this a little bit deeper, I'll just click on the tank here. What ThinkIQ is doing is it's putting this data in context as is available from our model. So in looking at this particular tank, we could see we have our different attributes: agitation, inlet, outlet, level, etc. We could see what their current values are. We could see a little spark line telling us about the history of this over the last hour. If we wanted a little bit more detail, we could maybe drill into a trend, and we could see that particular batching process, and that's nice. But we could also go a little bit further and say, tell me about the material movements that have gone through this particular vessel. So if I click on the material flow icon, what I'm seeing now, and here let me take it to the top of a process. What I'm seeing now is the input feeds from our sweetener tanks into the batch tank, through the batch tanks to the use tanks, and I could navigate beyond the use tanks to the accumulation tanks. So we can see the different transactions that feed all of those, for instance. And this allows me to actually trace the specific material that goes into any particular batch of product that's made. In the material flow, I could do things like see information about a particular transaction. So I could see when was the transaction start and end, the amount, the beginning balance and the ending balance of that transaction, what its influence ratio is. So what influence ratio reflects is how much does that change the contents of the target tank. So it's possible to kind of have different ratios depending on what your process is. We could also drill into a trend, for instance, which will show a little bit more data in context. So it's a little bit tough to make out, but we have a tag here that is our inlet valve, which is open, then closed, then open again. And we could map that onto, I'll make this a little bit bigger. When it was open, we could see a filling event happening, then it was closed, nothing's happening there, then it was open again, etc. We have a little bit of agitation happening there, and then we can see each of the discharge steps that take place here. And all of that, you could easily see mapping back to, we had two different fill events going into this batch tank, and then 1, 2, 3, 4, 5, 6, 7 discharge events going out of it to the use tank. And each of those discharge events, of course, happen at a different time. And so they're all segmented by time. And then from the use tank, we could see that the material goes out to its respective accumulation tanks. So the material flow is really instrumental in the ThinkIQ application. It's all about bringing about visibility of materials traveling within your process, within your factory. But the profile that we use to create this simplifies the actual building out of the application that facilitates it, because now I have an equipment definition that is easy to map onto. But it doesn't have to stop there. To take analytics a little bit further, that same equipment definition could be used to generate simulations. So in this case, I'm using a Jupyter notebook and I'm referencing the different sweetener tanks and batch tanks and so on and so forth to generate simulated data. And effectively, I can test things by running them in simulation, but using the definitions from my ThinkIQ system, many of the type definitions being imported directly from the CESMII system. So it becomes quite an accelerator as far as what can be done, because I don't have to spend so much time doing simple mapping of tags to equipment to different data definitions and repeating it again and again. Rather, I could do it once and ideally leverage the expertise of a machine builder and then just consume that expertise and use it in my applications. So I hope this gives a little bit of an idea of how smart manufacturing profiles could be utilized, how they can be built into CESMII Smart Manufacturing Profile Editor and consumed in applications designed to take advantage of them. With any luck, this gives you some ideas on how you can take advantage of that as well. I hope this was informative, and have a great day.